Hello everyone, and welcome to a very important topic in safety and loss prevention, and that is the topic of toxicology. This is the first lecture on toxicology, so it's focusing mainly on definitions, and much of it is self-explanatory, so I will run through a few things fairly quickly. However, there are certain things that need some thorough understanding as well. Okay, so first, definitions. Toxicology versus toxicity. What is the difference? Okay, and as we can see, toxicology is the study of chemical or physical agents that interact with biological systems to produce a response in the organism, and it's usually an adverse response. Okay, so toxicology refers to the study of the chemical or physical agents and the response that they produce when interacting with an organism. Toxicity, however, is a measure of the relative ability of a substance to cause injury or to biological tissue, so to cause adverse effects, and these could be adverse effects ranging from something simple like a skin irritant right up to the other end of the spectrum where it can cause the death of an organism. Okay, so toxicity is typically measured in the following units. Okay, so there are various types of toxicity measurements, but many of them are measured in terms of either in weight measurements or even molar measurements, so milligrams per kg, micrograms per kg, parts per million, or even parts per billion. These are all, remember, dimensionless measures, so even parts per million, it's essentially a mass per 1 million mass units, or in terms of moles, it's 1 mole per 1 million moles. Okay, so these are for concentrations essentially. Okay, so there's also various other types of measurements, such as like surface area. So for substances that in particular irritate the skin or actually get absorbed into the skin, we look at it in terms of the skin surface area, so milligrams per centimeter squared. When it comes to toxins being in the air around us, where it can be inhaled, then it's typically measured in terms of either milligrams per meter cubed of air or parts per million in volume terms for air. Okay, so toxicity versus a hazard. Okay, so toxicity refers to the capacity of a material to produce an injury or do harm. Okay, so that focuses essentially on the material itself. The hazard, however, is the possibility or the potential of exposure to a material that will cause injury when a specific amount is used under specified conditions. Okay, so you can have a material that's highly toxic, but if it is stored in a closed bottle in a fume hood, then the hazard itself is actually not that very high. Okay, so that's the difference between the toxicity and the actual hazard itself. Okay, effects of exposure to a toxin depend on the following. It depends firstly on the dose of that toxin. How much have you been exposed to? Right, the absolute dosage, and also the rate of exposure. Okay, so how long have you been exposed to that particular dosage of that particular toxin? It also depends on the physical state of the material. Okay, certain compounds, when they are solids, they are essentially safe. However, if you melt them down into a liquid state or vaporize them, then they can become very toxic. Okay, it also depends on the temperature as well as the site of absorption or exposure. Certain chemicals can be fine if it is spilled onto your hand. However, if it is ingested or if it's inhaled, then it can become a very dangerous toxic hazard. Okay, so these are all issues pertaining to the material itself and the environment. Then it also depends on the individual who is being exposed to the toxin. Okay, so that could be related to the individual's diet. Perhaps their diet affects their health. Okay, so their general state of health, and that can affect their reaction to a particular toxin. Okay, so not everyone would have the same reaction to a particular toxin. For some, it might be fairly mild. For others, the toxin can even lead to severe illness or even death. Okay, so in terms of the dose and response relationship, okay, there is a common saying: the dose makes the poison. Okay, the characteristics of exposure to a chemical and the type of effect caused by the chemical. In other words, how exposed and how much exposed to that causes the effect being studied. Okay, so we can look at it in terms of dose-response curves. In the case of an individual, it can describe a graded response to varying doses of a chemical. So let's say if an individual is exposed to various doses of ethanol, right? So this is just a single individual. And if we expose him to various doses of ethanol, and we can record his responses. Okay, so at a low dose, there might be no effect on that individual. On a higher dose, it could make the individual giddy. Higher, it could make him sleepy or even deep sleep. A higher dose could lead him to become unconscious or have labored breathing, and at the extreme case, that can lead to death. Okay, but that is just for a single individual. Remember that the effect of the exposure depends on the individual himself as well. So that's his general state of health as well. Now, so recording a study based on a single individual is often not very helpful. Typically, studies need to be conducted on a larger population to establish a distribution of responses to different doses in a population of individuals. Okay, so this is, for example, a mouse population studying the carcinogenic effect of benzene. And we can see at low doses, there's essentially no measurable response in the entire mouse population. However, as you increase the dose, there are cumulative response rates to that mouse population. Okay, and as you increase the dose, you can record the responses as well. And this is based on the entire population. Okay, not just one individual mouse. Okay, so just out of interest, a lot of toxicology and toxicity studies are conducted on small mammals, and that includes mice and rabbits as well. In terms of the measurement, they conduct various studies by exposing a population of mice or a population of rabbits to a certain chemical, and they note the response of each individual in that population to that particular chemical. And once that is done, we can get a dosage response in terms of, as you can see here, milligrams per kg. Okay, so that's milligrams of toxin per kg of organism, essentially. So if we're looking at mammals, even though we're conducting studies on very small mammals, our studies can be extrapolated to establish the equivalent proportional dosages for us as human beings or even larger animals. Okay, some definitions. Okay, so NOAEL, that refers to no observable adverse effect. Okay, so at very low dosages, the body is able to eliminate toxins fast and efficiently enough not to see any adverse effects. Okay, so remember, as mammals, our bodies do have a certain system of removing toxins. And if the dosages of certain chemicals are low enough, our body can remove those toxins fast enough and efficiently enough so that our body doesn't experience any adverse effects. Okay, so that's no observable adverse effect. The threshold value refers to the dose at which there are no ill effects from exposure. Okay, so eventually the body reaches a point where toxins in is equal to toxins out, and that is your threshold term. Okay, and thereafter your LOAEL, that is your lowest observable adverse effect level. So this is the lowest point at which you do experience adverse effects. Okay, however low those effects may be, it could be just maybe a slight dizziness or a slight skin irritation, but the fact is it is an adverse effect. Okay, so that's the lowest observable adverse effect level. Okay, so looking at it on a graph in terms of a response curve, so as we increase the dosage concentration, so milligrams per kg, as we increase the dose, you can see that for quite some time, your body will be able to handle the increased dosage of toxins and remove those toxins from itself. So there's no observable adverse effect. Thereafter, a threshold level is reached where your toxins in is equal to toxins out. So your body has reached its maximum capability of removing those toxins. Now anything thereafter, if you look at higher concentrations of those toxins, you're going to eventually get a low adverse effect happening. Okay, as I mentioned, it could be maybe just slight dizziness, a slight headache, some slight skin irritability, depending on the chemical that we're talking about. Okay, so that's your LOAEL. And thereafter, as we increase the dose, then you can see quite a significant jump in your responses in terms of adverse effects that are happening to your body. Okay, now when looking at it in terms of a population, so let's say if this graph represents the general population and how they react to a particular chemical, as we move up, you can see the higher the dosage, if it gets to a very toxic dose, it can lead to death. Okay. LD50 over here stands for lethal dose 50, and this is typically the dosage required to adversely affect or even kill at least 50% of the population that you've studied. Okay, we'll talk about this a bit more as we go along. Okay, so looking at some acronyms, TD low, TDLO refers to toxic dose low. This is the lowest dose by any route except inhalation. Okay, so when we're talking about toxicity and the way toxicity is measured, remember it depends on the route of exposure. Okay, so in cases where someone is ingesting a chemical, or if it is being injected into them, or if it is seeping through their skin, then we have a toxic dosage, right? And it's measured in terms of milligrams per kg or milligrams per cm squared. Remember, for chemicals that get absorbed through the skin, or it's also measured in ppm, either in mass or in molar terms. And this can be given over any period of time, and it's reported to produce any toxic effect. Okay, so it's TD low, the lowest dosage to produce any adverse effect, any toxic effect in humans, or produce any tumors or reproductive effects in animals. Okay, now remember this covers routes of exposure including ingestion as well as absorption into the skin. If we're looking at inhalation, then it's measured in terms of a concentration. Okay, the lowest concentration in air. Okay, that would be required to produce any toxic effect. Okay, and it's measured in ppmv or milligrams per meter cubed of air. Okay, and this is also over any period of time, and it must produce any toxic effect. Okay, so lethal dose low, that's the lowest dose of a substance by any route except inhalation that can cause death in a human or an animal. Okay, so it's quite an important measure. Lethal dose 50 refers to the calculated dose expected to kill at least 50% of a test population by any route except inhalation. Okay, so that's LD low and LD 50. For inhalation, we have correspondingly LC low and LC 50. Okay, but again, it's the same principle. Okay, the concentration in air that's required to kill at least 50% of the test population. Okay, so we can perform measurements over various chemicals, all types of chemicals, and we can establish an LD50. Okay, and we can use that LD50 to actually benchmark the toxicity of chemicals in relative terms. Okay, so how bad is it? Again, it's all relative. Okay, the lower the value of your LD50, that typically indicates the more toxic the chemical is, because remember, it's the dosage that's required to kill at least 50% of the population. Now, if the dosage is very low, it indicates that that chemical is actually very toxic, very dangerous. Now, an important part about toxicology is that, remember, in theory, every chemical is toxic to us. Okay, it just depends on the dosage. Even water can be considered toxic to us. Okay, so I know you've probably heard that on average, you need to drink at least maybe 8 glasses of water per day. However, if you are someone that wants to try and beat that, if you want to drink maybe 20 glasses of water per day, that can actually be quite a toxic dosage for you. Okay, it can essentially cause you to drown in your own fluids. Okay, because it essentially, by reverse concentration, the water gets into your lungs. So remember, any chemical is toxic. It can theoretically be toxic. It all depends on the dosage. Okay, now how do we convert LD50 into something a bit more meaningful? Remember that typically our studies are done according to the use of smaller mammals such as rats or rabbits. Now your LD50 gives a rough estimate of the toxic potential of a substance. Okay, for an average male weighing 70 kg. So let's say, for example, if we have a benzene LD50, and if we found that the LD50 is equal to 930 milligrams per kg of rats. Okay, remember that rats are, of course, of different weights as well, so you have to record the weight of the rat and the dosage that the rat has been exposed to, and then that is how you end up with these values. Okay, there is a tutorial on toxicology. In your tutorial, there is an example concerning rats and their mass, and you'll have to use that to find, to perform certain calculations. So your benzene LD50 is 930 milligrams per kg, and that's done by testing it on rats. For a 70 kg human adult male, you can calculate the lethal dose by simply multiplying. So 930 milligrams per kg multiplied by 70 kgs, and that will give you 65.1 grams. So what this tells us is that 65.1 grams is the amount that would kill at least 50% of a population of humans who weigh 70 kgs each. Okay, so converting this into volume terms for benzene, okay, so 75 milliliters. Okay, so just a recap: factors that influence toxicity in greater detail. It depends on chemical factors, composition, physical characteristics, properties, the presence of impurities as well, breakdown products as well as a carrier. It depends on exposure factors, the dosage or the concentration, the route of exposure, and the duration of the exposure. In terms of the person exposed, it depends on their hereditary traits. It depends on the strength of their immune system, their nutrition, their hormones, their age, whether they are children or adults, their gender as well is a factor, as well as their health status and any pre-existing conditions, cholesterol, diabetes, that can aggravate it and essentially increase the adverse effects of any particular chemical they're exposed to. Okay, so environmental factors, any additional chemicals present, the temperature, the air pressure, those are all factors that can affect toxicity. Okay, so the following typical routes of exposure of any chemical is typically ingestion, injection, inhalation, or absorption. Okay, other definitions concern combined effects of toxins. Okay, so that includes synergism, where certain chemicals, if you combine them, they cause a greater additive effect on the overall toxicity of the mixture. Okay, so ethanol and carbon tetrachloride, they are both toxic. They both have a certain LD50 or an LC50, but if you combine them together in a mixture, they become even more toxic. Okay, so enhanced hepatotoxicity, and we'll look at these definitions as we go along as well. Okay, then there's the other effect of potentiation, where the added chemical is a potentiator, but not necessarily toxic by itself. Okay, so you have a certain chemical that's not really toxic by itself, but if it's added to something else, it can increase the toxicity of that toxin. Okay, so carbon tetrachloride is hepatotoxic. Okay, hepatotoxicity is essentially referring to damage to the liver. So this is very bad for our liver. Isopropanol on its own is not toxic to the liver. However, if it's added to carbon tetrachloride, it increases the hepatotoxicity of carbon tetrachloride. Okay, and another final definition, antagonism. Okay, antagonists are chemicals that when combined, they actually lessen the predicted effect. Okay, there's 4 types of antagonists. Some are functional antagonists, where one chemical can have an opposite effect on some physiological function. You can have a chemical reacting with a toxic compound and make a less toxic product. Then there's dispositional antagonists that alters the absorption or the metabolism or distribution or excretion of the toxin. Okay, so this essentially is reducing the surface area for contact, if you want to be like really technical about it. But essentially in an organism, it's altering the ability of that toxin to actually be absorbed into your tissue and cause an adverse effect. Okay, and then you get receptor antagonists, which bind with your tissue, and that essentially deprives the toxin from binding into your tissue and causing an adverse effect. Okay, so it blocks the toxin, or it reduces its effect. Okay, types of toxicity. Right, further definitions. Acute toxicity refers to an exposure to a toxin that's usually within 24 to 72 hours. However, it can be up to 14 days of exposure. And it may be as serious as death or temporary as drunkenness or dizziness. Okay, then there are chronic toxicity measurements, which measures the effects manifesting over several weeks, months, or years of exposure. Okay, and this could be an isolated exposure. Let's say you're exposed once to it, and you look at the chronic effects for years and years, or you could be exposed to it repeatedly over many years. Okay, a good example of this is asbestos. Asbestos products, remember, on their own, they're not really that toxic. However, in the production process, asbestos dust is very toxic to us. Okay, so you can breathe it in once, and if you just breathe it in once, it gets stuck into your lungs forever. Okay, and you face chronic conditions for the rest of your life. Your lungs deteriorate slowly for the rest of your life. Okay, this is because it essentially cuts your alveoli in your lungs and creates a lot of scar tissue, so your lungs function less and less every time. Okay, then in terms of exposure to the toxin, there's also local toxicity, where your action of the toxic substance is isolated to a specific area of contact. So let's say if you got exposed to a chemical, it got spilt on your hand, and only your hand is affected. So that's local toxicity. Okay, so exposure to the skin or to the mucous membranes, to your eyes, or maybe just to your throat. Okay, and then there is systematic toxicity, where it doesn't really matter how the exposure happens. You could breathe it in or it could be spilt on you, but the effect or the action is distributed throughout the body. Okay, so for example, inhalation of chloroform can affect the brain, even though your brain is not directly exposed to it. Okay, and a few more definitions. Carcinogenicity refers to a substance that will induce a malignant tumor. Okay, so carcinogen, essentially cancer causing. Okay, so in a person following reasonable exposure. A mutagen affects the genetic system of a person or an animal that is exposed. It may cause cancer or undesirable mutations in future generations. So this affects one's own body as well as one's progeny as well. So if they have kids, they might end up with certain genetic problems. Okay, then there is teratogen or teratogenicity. It's a compound that doesn't necessarily affect the person itself. However, it can affect your progeny. It can affect, let's say, either the sperm, or it can affect a fetus in a pregnant woman. And that can cause death or significant deformities in the baby that is born. Okay, and in some cases, it might have absolutely no effect on the mother. Okay, so there was a case typically in Chernobyl. Okay, so there was a case, yes, in Chernobyl, where a pregnant woman was exposed to radiation, and essentially the radiation didn't really affect her because it all got absorbed. It went through her bloodstream and got absorbed by her baby, by her fetus, and her baby was born a stillborn, and she was absolutely fine. And it was actually quite a rare case of someone's unborn child actually saving their life. Okay, now common classifications of materials at waste sites. Okay, so there are a lot of things that people imagine when we talk about toxicity. Okay, when I know there's a lot of images created by the movies, essentially. When we think of the word toxic, we typically think of something, like a green chemical, and if it falls on you, your skin and your bones will melt off, or, some kind of, blotches and lumps to your skin. Now, that is essentially just one type of toxic effect, an adverse effect. Okay, so a toxin, remember, toxicity refers to causing any kind of adverse effect. It could be respiratory problems, it could be just skin irritants. Now, typically what we see in the movies are typically your corrosive toxins. Okay, so once you're exposed to them, they fall on your skin. Your skin can essentially react and melt away. If you have enough of it, if you fall in a tub of corrosive, like a tub of acid, then essentially your whole body can melt away. Okay, so that's known as your corrosives. Your irritants typically just irritate, they cause inflammation to various parts of your body, or even rashes on your skin. Hepatotoxins, typically they attack your liver, so they damage your liver. Nephrotoxins are toxins that cause damage to your kidneys. Okay, and remember, as I said, theoretically any chemical is toxic. It all depends on the dosage amount. Okay, so in the case of nephrotoxins, there are many types of painkiller medications. So ibuprofen, for example, I'm sure you've heard of chemicals of medicines like Nurofen. They contain ibuprofen. Okay, it's a fantastic painkiller, but if you take it at very high dosages, it can actually damage your kidney. It's toxic to your kidneys. Okay, then there are brain toxins. Okay, so these cause brain disease, diseases such as Alzheimer's. And interestingly enough, your brain actually works on trying to get rid of toxins, and it gets rid of toxins while you're sleeping. Okay, so which is why sleep is quite healthy for you. Okay, then there are toxins called cardiotoxins. Now, these toxins, they affect any kind of muscle. They affect your muscles. Okay, so remember that your heart is a muscle, and although these toxins affect all kinds of muscles, most of the time you'll feel the adverse effect in your heart. Okay, because it's one of your most crucial muscles. So that is why they are called cardiotoxins. Okay, so these typically affect all of your muscles, but specifically you'll feel it in your heart more than anything else. Okay, it also affects your bone marrow. Okay, then there are neurotoxins, which affect nerve tissue. Okay, so your snake bites, your snake venom, these are typically neurotoxins. They affect your nerve tissue. Okay, then there are ocular toxins that damages your eyes. Okay, can cause blindness. It could be temporary or permanent blindness. Okay, a good example of that is cobra venom. Okay, then there are pulmonary toxins that affect your lungs. Remember, as I mentioned before, water is a potential pulmonary toxin. If you drink too much of it too quickly, you can actually drown in your own lungs. Okay, then there are also bone toxins that weaken your bones over time. And then there are behavioral toxins that essentially affect your hormone levels, your dopamine levels. They can cause various types of anxiety disorders and depression. Okay, so that affects your hormone releases, or your hormone levels. Okay, now many of these types of toxins, often many chemicals, are not simply just toxic to one part of the body. They can contribute to a number of adverse effects and be categorized as follows as well. Okay, now typical signs and symptoms of a person being exposed to certain chemicals as well as heat, that includes the following. Okay, so this is something that you can read on your own, but just to pick up a few, so behavior changes. So this is focusing on chemical exposure. Okay, so sure signs, things like breathing difficulties, coughing, dizziness, diarrhea, fatigue, weakness, lightheadedness. Okay, so nausea, tearing, and tightness in the chest, those are typically key features of chemical exposure to toxins. Okay, so heat exhaustion and heat stress. Okay, that can typically cause clammy skin, confusion, dizziness, lightheadedness, etc., weak pulse. Heat stroke, it can cause a number of symptoms, convulsions, confusion, you're sweating, unconsciousness, and at the extreme case, it can be fatal as well. Okay, so That is typically your definitions concerning toxicology and toxicity. There are a few more which we will pick up as we go along in the next lecture. Okay, so if you're watching this and if you have any questions, please send me an email and we can chat about it as well. So make sure if there's anything that confuses you, just make sure that you send me an email, and yeah, we can clear it up. Okay, so that is all for today's lecture, and thank you very much.